procedures are your like histogram, box plot, quantile plot, Spirovilk, Anderson-Darling, even Kolmogorov-Smirnov test. All these tests are better than those. Yeah. Any other question somebody want to ask? आज फरमादुल्ला साहब आए हुए हैं?
यस सर, मैं हूँ।
अच्छा, आप हैं, ओके। चलिए, आपको शेर सुना दिए मैंने, 2-4 समझ में आ गए मेरे ख्याल में।
जी सर, काफी अच्छे शेर थे।
अच्छा, चलिए ठीक है। अब मैं आपके कश्मीर जा रहा हूँ अभी 25 तारीख को, श्रीनगर। ऑल राइट, लेट्स गो फॉर द अदर पार्ट। आपको ये स्क्रीन दिखाई दे रहा है? पहले मुझे ये बताइए, ये स्क्रीन दिखाई दे रहा है? ये आर का स्क्रीन दिखाई दे? ओके,
यस सर।
now let's go for one sample t-test. First of all, one sample t-test. I have already given you idea where to apply one sample t-test. Let me just open this also. So this is the situation of one sample t-test, that we are given certain fixed value and we want to test that, right? Okay. So that is one sample t-test. Closing this. Now, how to apply one sample t-test in R? This is hypothesis testing problem. Please try to listen to me. These are the ages of certain people. I have put that under X. It contains 12 years, 30. Now, what is the question? Question is, can I say that the mean age of this population is equal to 30? This sample is coming from certain population. So I'm just looking at whether the mean age of this population is equal to 30 years or different from 30 years. 30 years or different from 30 years. So you can write down H0, please. H0 stands for mean. I'm looking for mean. So mu is equal to 30. Alternative, mu not equal to 30. Mu is equal to 30, mu not equal to 30. Alternative. So let me put the data at right place. So this is the data. And simple command is, I just have to give t dot test. Generally, any testing hypothesis problem is followed by dot. Chi-square dot test. Anderson-Darling dot test. ED dot test. Spiro dot test. You have already seen like this, right? Similarly, this is t dot test. T dot test for which? For variable x, and with mu is equal to whatever is under H0. Write down here, mu is equal to 30. That whatever is under H0, we need to specify. And you will get t value and p value, right? So press this. So this is your t value, which is coming up 2.3898 degrees of freedom. How many observations will be one less than the number of observations? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 minus 1, 10. So degrees of freedom is 10. And your p value is 0.037. 0.037 is less than 0.05. 0.037 is less than 0.05. And if it is less, hypothesis will be rejected. What was H0? Mu is equal to 30. Alternative, it's different from 30, right? So what is the correct answer? Correct answer is yes, hypothesis has been rejected. So mean age is not 30 years. It's different from 30 years. Now somebody may ask whether it is more than 30 or less than 30. You just look at the mean. So mean is given here. The true mean is not equal to 30. That's a correct answer. And this is the mean actually. The sample mean is coming out to be 51. That means people are higher than the age of 30 rather than the lower than the age of 30 in this population. So that is the final conclusion. Yes, please. Is this okay? Hello?
Yes, sir. Okay, sir.
Yeah. Now I'll take up another example of t-test. Here, the data is related to BMI. What is a BMI? BMI stands for body mass index, right? And if you are carrying a pen or pencil, So this is how the data look like. It is stored in BMI. So let me show the data here only. VIEW, view data. Okay. Let me put this data and view the data. So this is how the data is. It says BMI. So BMI of some people. The question is like this. Please try to understand. Somebody being population, and somebody was observing population, and he came to know that this population are having, people are moving toward, they are having obesity or overweight problem, right? So one idea stuck to his mind, that why not to test their BMI level, because BMI level is an indicator of obesity, overweight, underweight, etc. And those people whose BMI level is less than 20, they are considered as underweight. Between 20 to 25, it's a normal BMI level. 25 to 30, between 25 to 30 is overweight, and beyond 30 is obesity, obese. Now, he want to check, what is the problem? He want to check whether these people are having normal BMI level or not. So if they have the normal BMI level, that means their BMI should lie between 20 to 25. So you can take any value, maybe 22.5, maybe 23 as a null hypothesis. So null hypothesis, you can write mu is equal to, suppose 24. I write mu is equal to 24. 24 lies between 20 and 25. Now, if I accept this hypothesis, then there is nothing to worry. People are okay, fine, no problem. But if I reject the hypothesis, then I have to be careful whether the people are moving towards obesity, or they are having underweight problem, or they are having obesity problem. Answer to this is given by, again, one sample. All right. So I'm just closing the data. So read this data. I have already gone through. View we have seen. So this is our data of BMI. So this is all BMI levels. So t-test for the data, and mu is equal to 24. So I'm testing whether mu is equal to 24 or not. So this is what is coming up. This is the t-value. Degree of freedom is, there are 25 observation, degree of freedom is 24. This is a p-value. So 3.887 into 10 raised to power minus 5. So obviously it's a 0.00003. It's very highly significant. That means definitely H naught, which is mu is equal to 24. That means these people are not having normal BMI level. The question is, which type of level they are having? Underweight, obesity, overweight. Look at the mean. Mean of exercise 31. 31 is beyond 30. Beyond 30 means people are moving towards obesity. So your conclusion will be, definitely they are not the normal people. Their weight is increasing. You have to ask the people that please don't eat pizza, burger, noodles. Your weight is increasing, right? So that is the crux of the entire problem. Yes, please. One sample t-test is clear. Hello.
Yes, sir.
Yes, sir.
Now we move on to two sample t-test. Two sample t-test. Just remember the example of West Bengal and Assam people. These are the, let's say, some data related to Bengal. This is the data related to Assam. Maybe it is the weight of the people, right? Weight of the people. And some people are having some of more weight, some are having less weight, and something like this in certain age group. We want to compare. So X is independent of Y. So it's a two sample t-test or independent t-test. So run, this is your data of X, this is Y. So this is how I'll go. T-test XY. Now, whenever we say t-test XY, these two data sets, because we are testing mean, what is our hypothesis here? I'm testing that mu1 is equal to mu2. Actually, this will test the hypothesis that mu1 is equal to mu2. This is what I'm testing, H naught. So my H naught is this, H naught. So this is your H naught. Mu1 is equal to mu2. Now, whenever we test mu1 is equal to mu2, I'm silent about the variances because your variances may be same. Variance of X may be same as close to variance of Y, right? If that is the case, we write this thing, variance equal to is equal to true. But generally, if I simply write T dot test XY, it will give you that the variances are not equal. Variances are not equal. So let me apply both. First of all, apply this. So this is, the p-value is coming out to be non-significant. This, because p-value is non-significant, that means there is hardly any difference between the weights of X and Y. Hardly any difference between the weights of X and Y. But this is to assume, by assuming that the variances are equal, that the variances of these two are equal. But it may not be. If variances are not equal, then we have to apply this test. Basically, this test is better, the second one. So again, t-test, it's coming out to be t-value and a p-value is same. So whether you apply equal or not, results is almost same. So conclusion here is yes, there is no significant difference between the weights of the two type of people. One is put into X, another is put into Y. Yes, please. Is this okay? Two sample t-test. Hello.
Yes, sir.
Now we move on to paired t-test. Paired t-test. Suppose these are pair observation. Let's say this is the weight, initial weight, this is after giving some medicine. Initial weight after giving some medicine. Suppose this is present in pairs. Then we, on the same data, you can apply pair t-test. Although it is not advisable, I will not suggest, but just a hypothetical example. So t dot test xy, but paired is equal to true. So if you apply this, you will be having the pair t-test problem. This is the t and this is the p-value. P-value is 0.055. It's borderline case, but greater than point. P-value is greater than 0.05. Greater than 0.05 means the result is non-significant. That means the medicine is not effective. Medicine is not effective, right? And in one of the problem which has been given for me is to test the variances also, equality of variance. Can I test the hypothesis that sigma 1 square equal to sigma 2 square, right? And then I will tell you that either we have to go for this or this, right? So let's check the variance. So I already have the X and Y values. Let's look at variance of XY. It will give you a covariance basically. So this is the covariance between X and Y is 1028.3. But we are not interested in covariance. We are interested in variance. You can write down the H0. Your H0 is sigma 1 square equal to sigma 2 square. Or what I'm testing, that sigma of X square is same as sigma of Y square. That means the variance of X is same as variance of Y. So it will test that. And the test given is, that is called variance dot test. So variance dot test X and Y. So let's test this. So it says this is the F value, degrees of freedom. Yes. It says that P value is non-significant. That means you can assume that both X and Y, they are having equal variances. If they are having equal variances, then obviously this test is better. Variance dot equal equals true. That means variances are equal. Then you should compute this. If variances are not equal, then you should compute this, right? So that is the testing of the equality of variances, testing equality of two variances. Sigma 1 square equal to sigma 2 square. And in PPT also, if you see, that was the next PPT actually. Let me go through PPT. Yeah, I think it was here. Yeah. F test is used for equality of two population variances. So it will give you the F value and corresponding P value. This is the test we have applied. Our hypothesis was this. Can you see this slide? Yes, please. Hello. Can you see this slide?
Yes, sir.
Now here we are testing sigma 1 square equal to sigma 2 square. Sigma 1 square, that means x values. Sigma 2 square, y values. I want to compare variances of the two in the population. I have just taken a sample. So I'm testing this hypothesis. And once we tested this hypothesis, the result is this. What was the result? F test to compare two variances. It says the result is non-significant. When the result is non-significant, H naught will be accepted. That means, yes, variance of X and Y, they are approximately same. They are approximately same. So that is the crux of testing this hypothesis, variance loss test. Another example of t-test. Another example of t-test is this one. Another example of t-test. Let me show you the data so that you will be clear about this. I'm just reading this file. This file is a CSV file, t.test CSV. Let me show you the data. So data has been gone into the memory, and C attach data. Attach data means it will attach all the variables. And if you see, put this as say head data. I'll just remove this. If you see head data, you can see all what are the variables here. So these are the variables. Okay. Let me go through another one. View data. So if you view the data, I'll then explain you better. Now look at this. There are two types of groups. One is PG group, another is UG group. And these are their IQ levels. Problem is like this. UG and PG, they are the two independent groups. Please try to understand the problem. There was an industrialist and he want to hire people for his industry. And there were two types of group. One, those who have done post-graduation, that's a PG group. Another people, those who have not done post-graduation, that is UG group. All right. Now it's a semi-skilled kind of work, and he hired two people from either PG or UG. But question here is, if he hire people from UG group, he has to pay less salary because they are less educated. And if he has to hire people from PG group, he has to pay more salary. And obviously, every industrialist wants to save salary. All right. Is the problem clear? Yes.
Yes,
Now, question is, one idea struck to his mind. What was the idea? Let us check their IQ levels. If IQ levels of PG and UG group, they are same. Let's say mu1 is equal to mu2. Their mean IQ levels are same. So then obviously he will hire people from UG level because he will save the money. He will hire people from UG. But if there is a difference in IQ levels, obviously he has to be careful which group is better. You follow the question or not?
Yes, sir.
Now, we will test this thing. PG and UG group, whether they are having the same means or there is a difference. So it's a problem of independent t-test. So I close this. Now group is not a factor here. So I'll define this group as a factor because it's written in string, the string variable PG and UG. So I take this group as group. There is a mistake here because group is written in capital. You see, it's capital. I have written it small. Otherwise, this would have given me error. Okay. I've taken this as a factor. Now t-test IQ level. If this is the data available between the two groups, then you can put IQ, then curl, and group data is equal to data, and variance dot equal is that the variances are okay. Again, same thing. So this is the t value. So here t value is this. P value is 0.001. Now p value is less than 0.05. Yes. Is that okay?
Yes, sir.
So p value is less than 0.05. That means hypothesis will be rejected. The person's claim was that the IQ levels of PG and UG level, they are same. But it says no, it's not same. So his claim is rejected. Right? Now, question is, which one is better? Whether PG IQ is better or UG is better. It's given in the last line. The mean group the mean in group PG is 95 and mean in group UG is 79. Which one is better? Can you tell me PG or UG is better?
PG with higher IQs.
Yeah.
Mean.
So obviously, whatever he was thinking that I'll hire people from UG and save money, that idea was wrong. He has to hire people only from PG group. Is that okay? Yes, please.
Yes, sir.
Okay. Now, this is all about t-test. Now we will move on to analysis of variance. First, we will do one-way analysis of variance, and then we will do two-way analysis of variance. And finally, we will move on to cluster analysis. Okay. Now, where to apply one-way analysis of variance? Because there is a restriction of t-test. Restriction of t-test is you can compare only two groups. That's all. Maximum two groups, PG and UG. But suppose there are three groups, four groups. Let me give you an example. Suppose in India there are three types of boards: CBSE, ICSE, and state board. All of them, they are conducting 10th class examination. Now somebody is interested to check or to see whether the performance of all the boards, let's say 10th class students, is it the same or there is a difference. So let's say mean parameter for CBSE is mu1, mean parameter for ICSE is mu2, for state board is mu3. And I frame the hypothesis H0. You can write down mu1 is equal to mu2 is equal to mu3. That means the performance of all the boards are same. Alternative, that at least two may differ. At least two may differ. There may be difference in at least two. All the three may differ. There may be CBSE and ICSE same, but they may differ from, both of them may differ from state. It can happen. So we write alternative as, I cannot write mu1 not equal to mu2 not equal to mu3. I cannot. Because two may be same, it may differ from third. Or all of them may be different. You follow my point? Hello?
Yes, sir.
So in alternative, we always write at least two of them may differ. Now, question is, it involves three groups. One is CBSE, another one is ICSE, third one is state. Can I apply t-test? Yes or no? Yes, please. Can I apply t-test?
Can you please
No.
come again with the
No.
question, sir?
No,
My
we can
question
do
is-
only two sample. T-test
Yeah.
is only two independent sample.
Yeah, t-test is applicable only if there are two independent samples. But if there are more than two, say three samples or three populations or four populations or five populations, you cannot apply t-test. Not at all. Okay, you cannot apply t-test. Then we have to go for that is called one-way ANOVA. So just me go through the theory of one-way ANOVA and then you will be more clear. Okay. This we have already covered. Analysis of variance. Now, basically, ANOVA is called analysis of variance. Analysis of variance is a technique. Read the first line. Analysis of variance is a technique which partition the total variation present among the set of observations into number of components. Now, this thing will not be clear to you right now. I'll take up one example and that will make you more clear. Let me take that example. What I'm trying to say. So basically there are k number of groups and we want to compare all the k together. So hypothesis will be mu1 is equal to mu2 is equal to mu3 is equal to mu k. That is the null hypothesis. Alternative will be at least two of them may differ. Now this is the model for one-way ANOVA. Now this model is a mathematical model. Just try to understand first of all the crux of the problem. Then I will move on to this model. So here is the entire problem. Can you see this slide, please? Is this slide visible? This one? B1, B2, BK. Hello?
Yes, sir.
Okay. Now, whenever we go to market, Please try to listen to me carefully so that you can understand the crux of one-way Nova. Whenever we go to market, let's say I want to buy bulbs, electronic bulbs or tubes. Okay. Then some people have specific brand in mind. I'll go for Philips, I'll go for Bajaj, I will go for Samsung or something else. Yes or no? Yes, please. Some
Yes.
specific brand is there in the mind. Why we choose that brand? Because that brand is considered to be a good brand. It is having the maximum life length. Yes or no?
Yes, sir.
Right? So these are brands. Brand number 1, brand number 2, K number of brands available in the market. Now, let's say I take N1 number of tubes from brand number 1 and put them on test. So here you can see how the observations are. Y11. When the first tube, let's say it burns for 84 hours. So your Y11 is 84. Second tube, here, how many tubes I have taken from the first brand? 1, 2. Look at the first script. First script is fixed, 111. That means I am referring to brand number 1. But second script is varying, 1, 2 up to N1. That means I have taken N1 number of tubes from brand number 1. Is the notation clear? Hello?
Clear, sir.
Okay. Let's say I put the from the same brand, I put the second tube on test and it burns for 104 hours. So your Y12 will be 104. This was 84. So this is nothing but burning time or the lifetime of a component, of lifetime of a tube. So all these tubes are coming from brand number 1. N1 number of tubes. I have just noted down the how many hours a particular tube burns. That is my output. Similarly, I look at brand number 2. I take, let's say, Bajaj. Put the items again on test. 2 stands for that they are all coming from Bajaj. How many tubes I have taken from Bajaj? 1, 2, right up to N2. N2 number of tubes from Bajaj. And again, note down their life length. And so on. Here K is fixed from the Kth brand. 1, 2, right up to NK. NK number of tubes from the Kth brand. So total will be N1 plus N2 plus NK. How many tubes I have taken? Total number of observations will be N. N1 from here plus N2 from here, NK from here. So total number will be this. Is this picture clear? Yes, please.
Yes, sir.
All right. Now try to understand, please. Now, what is the problem here? Problem is I'm taking K different brands and their products, right? And noting down their life length. Now, there will be variation present in the data. Variation will be present in the data. It is not that I'll take 10 tubes from Philips. All the tubes will burn for equal number of hours. It happens or it doesn't happen. Yes, please. It happens or it doesn't happen. That all the tubes will burn for, all the 10 tubes will burn for exactly 104 hours. Is that happen sometimes? No. Yes or no? आपकी आवाज नहीं आ रही भाई किसी की भी कोई तो बोलिए.
Yes, sir. Within group
Yes, sir.
variation.
We are
Within
with
group
you.
variation is there.
Little bit of variation is going to be there. Yes or no?
Yes, within group variation will be there.
Yeah. So you see now you are coming to the point. There will be variation present in the data. Now this variation, the total variation present in the data, can be split up into 2 parts. How? One will be between variation, between brands variation. Why? Because they are coming from different brands, different material, different machines, different people are operating. So between variation will be there. Yes or no? आप में से एक बोलिए please.
Yes,
Between
sir.
variation होगा कि नहीं होगा?
Yes, sir.
Yes. And there could be within variation also. Within the same brand will also be variation. Yes or no?
Definitely.
Definitely.
Yes.
But what do you think? Between variation will be more or within variation will be more? That's my question.
Between.
Yes?
Between
Yeah,
group variation.
between. Why between? Because they are coming from different material, different machines, different people are operating. But if you see within, they are coming from the same material, same person is operating, maybe same machine. So you will expect within variation to be less, but between variation to be more. So that means the total variation present in the data is sum of two components. Total variation will be equal to between variation and plus within variation. Yes or no?
Yes, sir.
Right? These are only two variations. Either they'll be between variation or they'll be within variation. Right? And between variation is likely to be more. Now, what do you think? If they are coming from the same brand, same material, same machine, same person is operating, actually, if you rightly think, there should not be any variation. There should not be, right? But you can expect variation. So within variation is obviously less than between. So within variation is sometimes also called error. Within variation is also called error. You follow my point?
Yes.
Okay. So now you go through the first line, which I have written. What is this? The one-way analysis of variance. Analysis of variance is a technique which partition the total variation present among the set of observations into number of components. So in one-way ANOVA, it split the total variation into two components. One is between variation, another is within variation. Is that okay?
Yes, sir.
But when I'll come to two-way ANOVA, you will see that total variation will be split up into three components there. I will show it to you. So let's complete one-way ANOVA first. Now, these are all your YIJs on the left-hand side. Suppose there are K treatments or K brands you can think of with N1 number of observations from brand number 1, N2 from brand number 2, NK from Kth brand, and your model look like this. What is this model actually? Yij is equal to mu plus alpha I plus Eij. Eij is error. Yesterday I told you what do you mean by error. Alpha I is the effect of the ith brand. They are coming from different brand, which I want to compare. Mu is that kind of thing which I cannot control. For example, I am sitting in Chandigarh. Some of you are sitting in Calcutta. I cannot say that I am taking more oxygen than you, right? Some things are, if I'm teaching to class of 50 people, I cannot say that I am standing, you are sitting, so I am taking more oxygen than you. So some things which are constant. We are living in the same environment. So to cover that component, we write the overall general effect, which is beyond your control. Alpha is the effect of the ith brand or ith treatment. Eij is error. So what is our aim? Our aim is to simply test Yij is your outcome. What is your outcome? These are your outcomes. So this Yij depends upon what? Mu is beyond your control. Error is beyond your control. So it depends only on one component. That is called effect of the ith brand. So it will depend upon what is the variation in the brand. Yes or no?
Yes, sir.
So that means that's why it is called one-way ANOVA. Because in one-way ANOVA, outcome depends only on one factor. And that factor is alpha I. So what is our aim? If alpha 1 is the life length of Philips, alpha 2 is the life length of the second brand, alpha k is the life length of the kth brand, average life length, then hypothesis will be that alpha 1 is equal to alpha 2 is equal to alpha k, that the life length of all the brands is same. Now, if the life length of all the brands is same, and I accept this hypothesis, then you are safe. You are safe, go to market, buy any brand. Yes or no? Experiment is over. Because life length of all the brands is same, mean life length. You can buy any brand. Experiment is over. There is nothing. Yes or no?
Absolutely, yes, sir.
Right? But suppose I reject this hypothesis. If I reject the hypothesis, then first question will come. Obviously, there are differences in brand. First question will come, which brand is better? Which comes at number 2? Which comes at number 3? And answer to this is given by one-way ANOVA. You follow my point?
Yes, sir.
Yes.
So let's see. So systematic procedure, let me just repeat, systematic procedure of splitting this total variation into two components is basically called analysis of variance. So you will get this type of table. After the analysis, I will show you in R, you will get this type of table. So here is the total variation. This is called total sum of squares. Then you will get between variation. Between variation is called between the sample variation. We call this as SST. SST means sum of squares due to treatments. Here, sum of squares due to brands you can think of. Now, how many brands are there? Can you tell me how many brands are there? Yes, please.
K number of brands.
K number of brands. So degree of freedom for brands will be K minus 1. 1 less than the number of brands. You can see K minus 1. How many observations are there? Total number of observations. How many?
And
N. So you can see degree of freedom for this will be 1 less, N minus 1. So it split the total variation. This is the total variation into two components. Between variation and within variation. You will get this type of result. Now there is no need to come. Within is called also error. There is no need to compute this error because TSS minus SST will give you SSE. Because it's a sum of this. If I know the two of them out of the three, you can compute the third one. Yes or no? If out of the three, there is some relationship, I know two of them, I can compute the third one easily, mathematically. Yes?
yes,
Now, how the degree of freedom for N minus K is here? Because N minus 1 minus K minus 1. 1 and 1 will get cancelled and you will get N minus K. Okay? Yes, please. Is this okay?
okay,
Then you will get mean sum of squares. How to get the mean sum of squares? We call this as mean sum of squares due to treatment. This is nothing but the sum of squares due to treatments divided by the degrees of freedom. Divided by K minus 1, you will get mean. Similarly, this is called mean square error. Mean square error is nothing but SSE divided by N minus K. And if you divide these two, you will get F value. And corresponding to this F value, you will get P value. And you just have to see whether your P value is less than 0.05, hypothesis will be rejected. What was hypothesis? This was our hypothesis. Alpha 1 is equal to alpha 2 is equal to alpha k. It will be rejected if P is less than alpha. If P is more than alpha, experiment is over. All the brands are having similar life length. Go to market, buy any brand. That's all, right? So this is called one-way ANOVA. Now, once hypothesis is rejected, let's say hypothesis is rejected. The next question comes, which brand is better? Whether Philips is better, Bajaj is better, Samsung is better. Then for further analysis we need to do. But further analysis we need to do only when H0 is rejected. Yes or no?
yes,
So that type of analysis is called post hoc test. And in R, there is a two-case post hoc test. It will give you comparison. It will compare one brand versus all of them. Then the second brand versus all of them. And you will come to know which brands are similar and which brands are different. So this is called one-way ANOVA. So I'll give you a demo before moving on to two-way ANOVA. So let me open the R file. This is one-way ANOVA. So let me read the file. So file is written as ANOVA 1. And I'll view the data and show it to you. This is the data. In fact, this is the data. So let's view the data, then you will be more clear. This is our data. These are the, how many brands are there? Let me check. One brand is Bajaj. Another one is Philips, Crompton, then Sylvania. There are 4 different brands. So my hypothesis will be, these are life length. These are life length. Actually, how I did this, it's just coming from this table. Just coming out of this table. If you compare here, you see, I pick up the first column, if you see it. This column, Y11 right up to Y1N1, substitute here and put this as Bajaj, 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 because they are all coming from Bajaj. Once Bajaj is over, then you see, I have taken this, the second one. Second column. That means Y21, Y22, and substitute here. So that is coming out of Philips. You follow the point or not? Yes, please. This is how I enter the data.
yes, sir.
All right. So now, so Bajaj, Philips, Crompton, Sylvania. And my hypothesis is, you can write down the hypothesis. Please always have a pen or pencil. Alpha 1 is equal to alpha 2 is equal to alpha 3 is equal to alpha 4. This is our H0. What is alternative? Can you tell me what is alternative? at least two of them may differ. Always write down this whenever you are framing H0 and H1 for ANOVA. At least two of them may be different. So closing the data. So I have shown you the data. Okay. So this is what, if you look at this thing, so life length and brands. So box plot, if you see, is happening. Okay. Because this actually line, first brands have to be taken as factor. Cut and substitute here. Now first take this as factor, then it will work. Is this? Where is the problem? Life length brands. Oh, I followed now. Actually, we don't require this thing. The reason is because I need to download a package which is called ggplot2. Just forget about it because you already know about box plot. So we'll just move on to ANOVA. So this is ANOVA, that life length brands, and AO model will be AOV. Yesterday we have seen linear model. This is ANOVA model. So ANOVA model, your dependent variable is life length and factor is your brands. So just run this. What is happening? Life length is not found. Life length variable is not found. Let me put this variable here because maybe some spelling mistake. Copy and Control D. Now, can you tell me where is the problem? Can you tell me what is the problem happening? I will tell you. I am able to recognize where is the problem. Yes, please. Anybody? Why it is giving error? If you remember, yesterday I told you that if I don't attach the data, then individual values are not available. If you remember, Hello?
Yes, sir.
Yes,
So
sir.
I just, in the box plot, I just did that. I didn't attach the data. So individual values are not available. So that's why it says life length is not found because it is in the data frame. So I just run this. So run this again and attach data. Now, once you attach data, everything will work. Even brand and this will work. This is working now. Box plot is also working. Everything will work. So I made a mistake because I didn't attach the data. Yes, please. Is that okay? Where was the mistake? Hello?
Yes, sir.
All right. Now, what do you think out of this? Yes. That this Crompton is having, this is a mean life length or median life length of the Crompton, very less. What about the Bajaj? This is this much. It's above 80 hours. This is just above 55 hours. This is the most maximum. So Philips is giving better results, Sylvan. So you can have some comparison, graphical comparison. Can you see that? Yes or no?
Yes, sir.
All right. So if I ask you that out of this box plot, which brand is having the maximum life length? Just look at the median of each. Which is having the
Philips.
maximum? Philips. Followed by
Bajaj.
followed by
Bajaj.
followed by Bajaj, and again further followed by Sylvania. Yes. And the last one is Crompton. But question still remains whether they are having the similar life length or there is a difference. So that is answer to this is given by one-way ANOVA. So I'll apply model. Run this. It has been run. So just look at the summary of the model. You will get that table. So this is what you are getting. Between the brands variation. Okay, how many brands were there? If you remember, how many brands were there?
A.
Yes, please.
Four.
How many?
4.
4. So degree of freedom for a brand is 3. How many total number of observations were there? 37. So now this is 33. Sorry. There were 37 observations, and so total will be 30. Total for that will be 36. 36 minus 3 will be 33. So this is residual or error. So error will be 33. Sum of squares between the brand sum of square, within the brand sum of squares. You divide 3695 by 3, you will get 1231. You divide 3539 by 33, you will get 107. Then you divide 1231 divided by 107, you will get 11 point, and corresponding to this there will be p value. So this is your p value. So p value is star. Star means it is significant or non-significant. Yes, please.
Statistically significant.
Statistically significant. What does this mean? That means there is a significant difference between the brands. Yes or no?
Yes.
Now question is, we have to go one step ahead, and this type of analysis, if you go one step ahead, is called post hoc test. So this is called post hoc test. But post hoc test to be applied only when H0 is rejected. Post hoc test, one of the important post hoc test is two-case test. So we can apply two-case test, and two-case test will give you which brands they are different and which are same. So now you see. This is the two-case HSD. Two-case HSD test of the model. If you apply, you will see. Crompton versus Bajaj. This is a p-value. Less than 0.05. So there is a difference between Crompton and Bajaj. Yes or no? Hello.
Yes.
What about Philips and Bajaj? What about Philips and Bajaj? P-value is 0.93. Yes, please. Is there any difference between Philips and Bajaj? P-value is more than 0.05.
No difference.
No difference. What about Sylvania and Bajaj? No difference. What about Sylvania, Philips and Crompton? There is a difference. Sylvania and Crompton, there is a difference. Sylvania and Philips, no difference. So Crompton varies from all, actually. Crompton versus Bajaj, significant difference. Crompton versus Philips, significant difference. Crompton versus Sylvania. So that means Crompton is having the lesser life length we have seen from the box plot. But others are very much similar. But if you see the shape of the box plot, it will give you a very, very clear picture. You see that this is having the minimum life length, Philips is having the maximum life length, but there is hardly any difference between Bajaj and Philips because it is non-significant. Bajaj and Philips are non-significant. Also, it doesn't differ much from Sylvania also. But out of this, the best one is Bajaj. Sorry, the best one is Philips, followed by Bajaj, followed by Sylvania. That is the answer given by one-way ANOVA. Is that okay? Hello? Anything you want to ask in one-way ANOVA?
Sir, my question is that we can see the significance or non-significance by the value of P when we will go for F calculated value, sorry, tabulated value.
F tabulated value is the overall comparison. See, there are two things. F will give you the overall comparison. Overall, it is testing alpha 1 is equal to alpha 2 is equal to alpha 3 is equal to alpha 4. That is the test given by alpha. Alpha says that its value is coming out to be significant. That means there is a significant difference between the brands. But this table will not give you any idea which brands differ. It simply says brands differ. That's it. But further to check which brands differ among themselves, we are applying two-case test. Is that clear? Hello?
Okay, sir.
If you have any doubt, please ask. If you have any doubt. If you have any doubt.
Actually, sir, my question is that when we see F tabulated value.
No, there is no need to see tabulated value because you just look at the p-value. Tabulated value, actually computed value is 11.48, and when we do the practical in statistics, we just look at the tabulated value. Tabulated value of F with 3 and 33 degrees of freedom, and we compare the calculated value with tabulated value. But
Yes, sir.
then what is the idea of software? Our software simply give you p-value. You just have to p-value is less than 0.05. You will get exactly the same result. Either you take that statistical tables or your result is based on p-value, you will get the exactly same conclusion. Why to look at the table then?
Okay, okay, sir. Thank you.
All right. Any other question? So one way is clear. Yes, please. One way NOVA is clear.
Yes, sir.
Okay. Now extension of one way NOVA is two way NOVA. Extension of one way NOVA is two way NOVA. Now what is the two way NOVA? I'm coming to two way NOVA, and then finally we'll go on to cluster analysis. So what is two way NOVA? Two way NOVA is an extension of one way NOVA, where your outcome depends upon two factors at the same time. Outcome depends upon two factors at the same time. So let me give you an example. That will make it more clear. Let's say, can you see this slide now? Is it visible?
Yes, sir.
Yeah. Just think like this, that there are plot of lands or a field, and I am using, let's say, 4 different type of seeds. Seed number 1, seed number 2, seed number 3, seed number 4, and 3 different type of fertilizers, F1, F2, F3, right? For example, this field will get seed number 1, fertilizer number 1. This will get seed number 2, but same fertilizer. So that means this is your outcome. Yij is your outcome. So your outcome basically depends upon 2 factors. One is type of seed used, another is type of fertilizer used. Yes or no?
Yes.
Yes? Hello?
Yes, sir.
So that means if your outcome depends upon 2 factors, it is called two-way NOVA. In previous case, outcome was result of only one factor, differences in brands. That's all. It will depend upon the variation in brands. But here it depends upon 2 factors. So anywhere, if your experiment depends upon 2 factors, like type of seed used, type of fertilizer used, then we use what is called two-way NOVA. And model will be mu, Yij is equal to mu, that's overall general effect, Eij is error. But here there are 2 factors, alpha I, beta j, where alpha I is the effect of seeds, beta j is the effect of fertilizers. So basically, in two-way NOVA, we are testing 2 hypotheses, 2 null hypotheses. One is testing the effect of seeds, that the effect of all the seeds, they are producing the same yield, or the seeds are producing the same yield. And another is fertilizers are producing the same yield, H01 and H02. So your seeds are represented by alpha 1, alpha 2, alpha p. There are p different type of seeds and q different type of fertilizers. So beta 1 is equal to beta 2. Yes, please. Is this okay? Hello.
Okay. Okay, sir.
Sir, yes,
Now-
yes, sir. Yes.
Now in two-way NOVA, only one factor will be added. So it will give you sum of squares due to levels of A, levels of seeds. Sum of skew due to sum of squares due to levels of B, levels of fertilizers, then error and total. So one more component is added. That's all. So column and row wise. There it was only column wise. Here it is also row wise. So you can think that this is column wise, this is row wise. And how many brands for how many seeds you have? P. So degree of freedom will be P minus 1. How many this Q? Q minus 1. Total will be P into Q. So PQ minus 1. If you subtract PQ minus 1 minus, put the bracket P minus 1 plus Q minus 1, you will get this thing. And then the same procedure, MSA, that means mean sum of squares. This divided by the degree of freedom, this divided by the degree of freedom, this divided by the degree of freedom. And then this, you will get 2 F values. First F1, F2. First F1 will test the first hypothesis. That means MSA divided by, we always divide by the error. MSA divided by MSC. That will give you for testing of the first hypothesis. Then second will be MSB divided by MSC. MSB divided by MSC. That will test the second hypothesis. So you will get 2 null hypotheses, 2 F values. That's why it is called two-way ANOVA, F1 and F2. F1 will check, is there any significant difference between the levels of A? F2 will check, is there any significance between the levels of B? Yes, please. Is the problem clear? Hello?
Yes, sir.
Now, next important question is, if I reject H0, suppose I reject H0, that means there is a significant difference between the levels of A. Further, if I reject H0, H01, I will apply post hoc analysis then, because I want to check which are similar and which are different. Again, I'll have to go apply 2K. Same way, if I reject H02, I have to apply 2K's test. But if I accept H01 as well as H02, experiment is over. You take any type of fertilizer, you take any type of seed, they are producing the same yield. Is that experiment clear? Hello?
Yes.
Okay, let's go for the analysis. So this is two-way ANOVA. Now in two-way ANOVA, I'll show you one data, and that will make it more clear what is happening. Otherwise, it is difficult to understand. Put it this way. Just give me 1 minute. Okay, this is two-way ANOVA. I'll explain you through this example. Can you see this slide of methods and age groups? Hello?
Yes, sir.
Now, experiment is like this. Try to understand the experiment. There is a machine, and people are given training to learn that machine. For example, whenever there is a votes are there, some polling is there, people are trained how to operate this voting machine. You remember? People are given training on how to operate this voting machine. So there is one machine, and people are given training on that. Now, there are three methods of teaching. Method A, method B, and method C. And it has been taught to different age groups. Some people are less than 20 years. Some are between 20 to 29 years, 30 to 39, 40 to 49, more than 50 years. And this is the time of learning. For example, if a person is less than 20 years, he has been taught by method A. So how many hours it takes to learn? 7 hours. Person is less than 20 years, but taught by method B, it takes 9 hours. Person is again less than 20 years, taught by method C, but takes 10 hours. So this is your YIJs. Time of learning is your YIJ. So it is time of learning depends upon two factors. One is teaching method, another is different age groups. What is the question? Which method is better? Number one, which age group learn fast? Answer to this is given by two-way ANOVA. Because your outcome depends upon two factors at the same time. One is method of teaching, another is age groups. Yes or no? Hello?
Yes.
Is
Yes.
the question clear?
Yes.
Yes, sir.
All right. Now, if the question is clear, then how to feed this data? Feed this data, I'll take up 7, 9, 10, the first row. This is how I'll feed the data. Insert table. Insert table. Sorry. Table. Insert table. So it is asking number of rows. Columns I require only 2. And rows maybe I require how many? 12. 12 rows are required because it's 3 into 5. 15 rows are required. 15. P into Q is 15. You can see 3 into 5, 15. So 2 columns. So this is how I need to feed the data. How I'll do? I'll put 7 here. Then I'll put 9 here. I'm just looking at the first row. Then 10 here. And I need to create one more. Insert column to the right. Okay. Now 7, 9, and 10. 7, 9, and 10, they are coming for method A. 9 is under method B. 10 is under method C. but they all belong to less than 20. This one is less than 20. This is less than 20. This is less than 20. Yes, please. Is this okay? I have written. Hello.
Yes, sir.
Then I'll pick up the second row, substitute here 8, 9, 10. And again write ABC because they all belong to ABC. But here the age group will change. I'll write 20 to 29, 20, and so on. This is how I need to feed the data. Is that okay?
Yes, sir.
So just closing this, I have given you the entire crux of the problem. Let's move on to this data set. So here is this data set. So attach data. This is two-way ANOVA. You can see. Now this is how I feed. 7, 9, and 10 method A, B, and C and less than 20. Then after that 8, 9, 10 method A, B, C again, but 20 to 29, then 30 to 39. Is that okay? Hello?
Yes, sir.
Okay, sir.
All right. Madam का भी आवाज आ गई है पहली बार आज. So attach data. Attach data is very important because now individual values are available. So methods are your factor. So change method to factor. Age groups are also factors, right? Then apply ANOVA. ANOVA. Now your Yij is this. Now you have two because it will split up into three components now. So there are two factors. One is method, another is age group. Data is with data. So you specify your model and then the summary model, and summary model will give you the same table. That's the same table. How many methods were there? Yes, please. How many methods? Madam, बताइए कितने method थे?
Sir, 3.
3. So how many degrees of freedom? 1 less. 2. How many age groups were there? 5. How many degrees of freedom are there? 4. So these are the sum of squares, divide, and this is your F1 value. This is F2 value. So F1 is 21.39, F2 is 14 point this, and they are significant. Both of them are significant. Now we have to apply, we have to move further or not to see which method is better and which method is not better. Yes, please. Is that okay? Hello.
Yes, sir.
Now go for the 2 case test. 2 case test says first it will compare methods. Method A versus method B. P value. What is the P value of method A and method B? Yes, please. This is a P value.
0.366.
So significant or non-significant?
Not significant.
That means there is no significant whether you teach by method A or you teach by method B. What about the comparison of C versus A?
Significant.
What about C versus B?
Significant.
Significant. That means C differs from B, C differs from A also. Is that okay?
Okay, sir.
Right. Now come to the age groups also. More than 50 versus less than 20 years of age group. Significant difference. So same way, if you compare less than 20 years with 40 to 49 years, again, where is the difference? Where is difference is 20 to 29 years. If you see the last one, I think you can check the p values, which one differs and which one not differ, right? Hello.
Yes, sir.
Right. So this is two-way ANOVA. The question is, which method is better? Which method is better? So I'll give you this exercise to you. So what you can do, you can look at the box plot. You can look at the box plot of time of learning against method. Against method. METHOD. Okay. Now, if you get the box plot, what will happen? Object method is there any spelling mistake? Is there any spelling mistake or what? Let's look into it. It's giving you object method is not found. Error in inspector. Okay, let's read the data again. Maybe read this data again. attach data. And let me go for the box plot. Now you see the box plot. So not a very good comparison to box plot. Doesn't look better. But only thing is method C, method A. Now you see which method takes less time. Method A and B, they are, I mean, method B you should not ignore because it's very less. This method A seems to be better because it is taking the method which will take less time will be better. Yes or no? Right?
Yes.
Same way you can check the box plot. Which age group learn fast? You just look at the box plot and you will come to know. So this is called two-way NOVA. So one-way NOVA and two-way NOVA. Any question in one-way and two-way NOVA? Hello? Yes, please. Any question in one-way and two-way, or should I move on to the next topic?
Yes, from me, sir.
Okay. Let's move on to now. What do you mean by cluster analysis? Let me go for cluster analysis. All right. Now, what do you mean by cluster analysis? Because I need to cover this topic and it will take around 15 to 20 minutes to cover this topic. What do you mean by cluster analysis? Cluster analysis means I want to combine those subjects or objects which are having similar properties and they should belong to a particular cluster. If they are having different properties, then they will go to the different clusters. If these two clusters, if there could be third cluster also, which are altogether different from cluster 1 and cluster 2. So dividing your data into dividing your objects or subjects into different groups basically make clusters. Let me give you an example of cluster analysis. Let's say I'm taking class from 12 to 1 and 1 o'clock is the lunch time, right? When students disperse, some 5-6 girls, they move in one direction. 3-4 boys, they move in one direction. Sometimes 2-3 girls and 2-3 boys, they move in another direction. It happens. Why? Because they take lunch together, they like their foods, they like their habits. It happens, yes or no? Hello? So this is what do you mean by cluster?
Yes.
And this cluster analysis is very, very helpful, particularly in the area of management, where they want to identify customers. Though I want to identify those customers who are brand conscious. I want to identify those customers who are price conscious. I want to identify some other people who are, let's say, looking into some other aspect of the questionnaire. So how to identify such things? We apply cluster analysis. So let me go through a theory of the cluster analysis and then we will move on to. Let's say there are two friends, they like each other, and the third friends, they also like their habits. So it has been clubbed together. So all of them, they form one cluster. This is just a picture to show. What is a cluster analysis? Cluster analysis is a class of techniques used to classify objects or cases into relatively homogeneous groups, and these homogeneous groups are called clusters, right? I mean, if they are having the similarity, they will form a cluster. Objects in each cluster will tend to be similar, but they will differ from the other clusters. The both cluster analysis, there are two techniques. One is cluster analysis, another is discriminant analysis. Both the techniques are known as classification techniques. Both the techniques are known as classification techniques. But where is the difference? Difference is that in case of discriminant analysis, you should have a prior knowledge that this is in this group and this is in this group. While no prior knowledge is required in cluster analysis. Only the data will speak. Data will tell you that how many clusters are there. That's the difference between discriminant and cluster analysis, right? Groups or clusters are suggested by the data, not defined a priori. Now let's look at a very ideal clustering situation. This is quality, this is price. These are the items which are low on quality but high on price. Low on quality but high on price. These are the items which are medium on quality, medium on price. These are the items which are high on quality, because if you read x-axis, they are high on quality but low on price. And these are the items which are high on quality and high on price. Yes, please. Is this picture clear? Hello.
Yes, sir. It's clear.
Yes, sir.
Right. So that means very ideal clustering situation. If this is the situation, you can easily make clusters. So how many clusters we have made? Hello.
4, sir.
4. But practical situation will be different. How the practical situation works? This is a real practical situation which we need to face. Now, question is, how many clusters are possible? It's difficult to see. Somebody can say 2 clusters are possible. Let's say I take these items into one cluster. Let's say I put these items into one cluster. And these items into one cluster. He will say 2. Someone can say, no, there may be 3 clusters. How? One cluster is this, another cluster is this, and the third one is this. Somebody can say, no, there are 4 clusters. How come? One cluster is this, another cluster is this, another cluster is this, and another cluster is this. Yes or no? So no clear-cut idea how many clusters can be formed. Hello?
Yeah.
So
Yes.
that's why clustering technique is important. And today we will make clusters out of such type of data. Right? Now, how this clustering techniques works? Please try to understand how this clustering techniques works. If there are 2 points, let's say one point is x1, y1, another point is x2, y2, then I can always look at the distance between 2 points. And that distance is called Euclidean distance. In short, it is written as ED. Euclidean distance is written as ED. So there is a mathematical formula to compute Euclidean distance. How it is computed? x1 minus x2, put the bracket and square that quantity, plus y1 minus y2, take the difference and square that quantity. That,
Sir, your slide is not moving.
pardon?
Sorry, your slide is not moving.
Not?
Moving.
No, I have not moved.
Slides are चल रही
नहीं, मैंने slide move ही नहीं किया. अब चल रही है.
Okay. Yes, sir.
I'm just telling you the formula of how the clusters are made.
Okay.
Right? Now, please try to listen to me. Now, obviously, there are distances in the dots. Can you see the distances in dots? Yes or no? There, for example, distance
sir.
between this, distance between this. Now, how the clustering works? It is based on a formula which is called Euclidean distance. Euclidean distance is always computed between 2 points. For example, let me pick up any center point. I'll pick up this point. This is there in the center. And this point, let's say the next close point is this. So it will compute the distance between these 2 points. Right? And once these 2 points, the distance will be computed, it will, both these points, they will be clubbed into one cluster because difference is very, very small. So in that particular circle, there will be 2 points. One point will be this, another point will be this. Are you with me?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes.
Now try to follow, please. Please be concentrate. There are 2 dots in your cluster. Now, it will take the mean of the 2. There will be another center. It will x1 plus x2 divided by 2, y1 plus y2 divided by 2. So there will be some another center. Let's say that center is at the close of the boundary. Then from that boundary, it looks into the another point. Which one is having the closest distance? The next is this one. So from that center, it will compute this distance. Again, there will be, if the distance is very small, then it will be clubbed into the same cluster. So all these 3 dots will go to one cluster. Are you with me? All these 3 dots will go to one cluster.
Yes.
Yes, sir.
Now, because their distances are very, very small, then out of these 3, center will be computed. How the center will be computed? x1 plus x2 plus x3 divided by 3, y1 plus y2 plus y3 divided by 3. You will get center somewhere here. Then from center, there are other points also. Then it looks into which point is, it will compute this distance, it will compute this distance, it will compute this distance. Nearby, it will compute all the distances. And then try to club that which is having the minimum distance. That will again go into this cluster. And it will keep on doing this up to. So for each cluster, there will be threshold. If your distance fall into that threshold, all those items within that threshold will be clubbed into that cluster. But once it crosses that threshold, let's say distance threshold is 4. So if the distance is 3.9, 3.8 for each and everything, 3.2, 2.9, it will go on clubbing till up to 4. But if any point is beyond 4, say 4.5, then it will start with the another cluster. For example, this distance is, let's say 4.5. It will start with another cluster and go on combining with the same technique. And then again for the second cluster, there will be second threshold. If all the points are within the threshold, it will go on combine. And once it crosses the threshold, it will start with the third cluster. And it keep on doing this till all the points are exhausted. Yes, please. Idea is clear? Hello.
Yes. Yes, sir, it's clear.
You will not have to do that. I'm just telling you the technique, right? Okay. Then there are certain statistics which is associated with the cluster analysis. One of the technique is called agglomerative schedule. What is agglomerative schedule? That means the technique which I was discussing, that it will start from any center, try to combine the points, and then it will go on combining if they are well within that threshold. Once the threshold crosses, it will go to the another. That schedule is called agglomeration schedule. Then cluster centroid. Every time you have 2 points, new center will be there. If you have 3 points, new center will be there. They are known as cluster centroid. And cluster centers, every time the cluster centers will be computed. Then cluster membership. What is a cluster membership? Whether this item will go to this cluster or to this cluster or the third cluster, that is a cluster membership. You will come to know. Then the most important thing in cluster analysis, once you apply this agglomeration schedule, you will get a picture. And that picture is called, just like histogram, just like box plot, you will get a graph, and that graph is called dendrogram. And from dendrogram, you will come to know about the approximate number of clusters. You will come to know about the approximate of number. In dendrogram, we usually look for the gaps. If there are 2 gaps, these are basically threshold points. If there are 2 gaps, then there will be 3 clusters. If there are 3 gaps, then there will be 4 clusters. So from dendrogram, we just look at how many clusters are possible. How many clusters are possible. Dendrogram will give you this idea only. Now, once you know how many clusters are possible, that is called K. K stands for how many clusters are possible. K may be 3, K may be 4. So there are 2 types of clustering techniques. One is called hierarchical clustering. Another one is called K-means clustering. Now, please try to listen to me. One is called hierarchical clustering. Another is called K-means clustering. Now, first we apply hierarchical clustering. Hierarchical clustering is based on agglomerative schedule. And agglomerative schedule will give you this dendrogram. Dendrogram will give you how many clusters are possible. So with the help of hierarchical clustering, you will come to know about K. K stands for how many clusters are possible. Once you know the number of clusters, then we move on to K-means clusters. But problem in K-means cluster is you need to put the value of K. Then and only then K-means will work. And K will come from hierarchical clustering. And K-means clustering is also called non-hierarchical clustering. And non-hierarchical clustering require value of K. So value of K will be known from hierarchical clustering. Put that value in K-means clustering, you will get the exact number of clusters. That is the technique which we follow. So I'll take you, these are not important. Vectoring cluster analysis, Euclidean distance I mentioned. I will make clusters out of this data. So this type of dendrogram shape will appear. Now, how many gaps are there? See, one clear gap is here. one clear gap is here. So that means there are two gaps. So these items will go to one cluster. These items will go to another cluster. These items will go to third cluster. So three clusters are possible for this data. This is the data. We'll make clusters out of this data. Right. So this is the entire clustering procedure. It's a hierarchical clustering, non-hierarchical clustering. First, we will apply hierarchical clustering. Look at the dendrogram, and it will give you how many approximate number of clusters are possible. So there are two types of methods which we generally used. One is called the centroid method. Another one is called the average method, or a complete method and average method. So I will be using these two methods, average method and complete method, to apply in hierarchical clustering. And once we know the number of clusters, then I'll be put that into non-hierarchical clustering. So that is the procedure we have to follow. So I'll take up the example and show it to you how the clustering can be made. It's the same data. So let me take the data of cluster analysis. Okay, so here is cluster analysis. So read this data into data 3. Already there in the folder. View this data. So this is the data. Actually, this is regarding whenever people go to a mall for shopping, they have with different mind setup. Some people think that shopping is a fun. If they have a lot of money, obviously for them, shopping is a fun. If they like it, that shopping is a fun, they will give this as number 7. But if they don't, then they will give this as number 1. So responses have been captured from 1 to 7 point scale. 1 to 7 point scale of certain respondents or customers. Then shopping is bad for budget. You can, I think, husbands should be asked from the whether it is bad. If it is bad for someone, he will give this as 1. If it is good, he will give this as 7. And some people, whenever they go to the mall, they also combine shopping with eating. That whenever we go for a shopping, today we will eat outside. If they like it, number 7. If they don't like it, 1, and so on. Responses are captured on a 7 point scale. So you can compare the prices by, you can save a lot of money by comparing prices. That is comparing this. And you could be brand conscious also. So some responses are there of the customers. Now, what is the problem? Problem is which customers are having similar habit and which are having different habits and which are having altogether different habits. So we want to make clusters out of this data. Is the data clear? Hello?
Yes.
Right.
Yes, sir.
So how to make clusters out of this data? So attach data first of all. And this data is a data frame now. This is a data frame. So head data will show you that shopping is fun, shopping is bad for budget, shopping with eating. You can shop while having the, you can say, I think this stands for, the best stands for something else. I just forgetting. Then you can save a lot of money by comparing and some other variable. So this is the data actually. So first of all, it will compute the distances, distance matrix. So distance matrix, the formula is distance of the data 3. So the technique, Euclidean distance, it will compute. So this is all the distances. If you look at D, it will give you a matrix, very difficult to read. But if you reduce this to, because there are 7, 8 decimals, I reduce this to 3 decimals, you can see the matrix. So this is with 3 decimals. So all these are the distances. Some distances are here. So those items will be combined first. Those who are having very, very small differences. Right? For example, 14 and 16. Let me tell you. Where is 14 and 16? This is 14 and 16. See, 14 and 16. This is 16. This is 14. 14 and 16 distance is 1.41. And I have already checked in. This is the minimum distance. This is the minimum distance. So 14 and items if I name the customers, 14 item customers will be combined into the first cluster. Then whichever is close to 1.41.
I have not understood it.
You can see it's a distance between all the points. It's a distance between all the points. It's difficult to see the matrix. What I'm saying that there are 20 different subjects, 1 to right up to 13. And after that, it starts with 14, 15, 16, 17, 18, 19. Okay. There are basically 20 because you have to take 2 at a time. So you cannot take the last one because last one distance cannot be computed. The reason is because you are computing the distance between the 2 points. You follow my point? Hello?
So that I have understood.
Now what this actually value? Let me tell you what is this value. This is the distance between 1 and 2. The distance is 8. Between 3 and 2, the distance is 8.25.
Okay,
That
sir.
means, yeah, between customer number 4, customer number 2, the distance is 5.57. So obviously those customers will be combined. Whose distance? First of all, those customers will be combined, which are having minimum distance, yes or no?
Yes, sir. Yes.
They are very much similar. So if you look at the entire matrix, if you look at this is 1.73, this is 1.73, somewhere, this is the minimum distance. 14 and 16. 14 and 16, 1.41 is minimum in the entire matrix. That means first item, plus, you will not have to see this actually, because you will get the dendrogram. That will give you a very, very clear picture. You will, this is just for a computation point of view, right? So you will see that 14 and 16 will be combined at the first stage. So apply hierarchical clustering. I have written the comment. Apply hierarchical clustering with complete linkage method. So if you apply hierarchical clustering, you will get this thing. So method has been applied. Now plot the dendrogram. You will see the dendrogram. This is the dendrogram. So this is the dendrogram, and 14 and 16 they are coming into one group. Now how many gaps are there? Can you see the gaps? One gap is here, another gap is here. Can you see? Yes, please.
Yes, sir.
Yes, sir.
So how many clusters are possible? Immediately you can see this is one cluster,
3.
this is one cluster, this is one cluster. So 3 clusters are possible. So that is your K. So what is the value of K now?
3.
Hello. So K is 3. So this is called hang 1. Hang -1 means slightly bigger picture, better picture. That will give you this. This is called hanging. But again, you will get the same picture. Then use the average method. Apply hierarchical clustering with average method. So I'm just using average method. Method is equal to average. A stands for average. HC stands for hierarchical clustering. So I am using this method and then plot this hierarchical clustering. And if you see the plot, it will look like this. So this is based on the average distance. Then, and hang 1 also you can check. This is hanged 1. Right? And then I will go through what do you mean by K means clustering. Now hierarchical clustering will give you the number of clusters, that there are 3 clusters possible. And K means clustering will ask you about how many clusters you require. Now how many clusters we require?
3.
3. So use this result. K means data is your data 3 and put the value of K. K is how much? 3. And you will get the results. So run this and look at the results. These are important results. That means there were 20 items. The first item has gone to cluster number 1. Second has gone to cluster number 3. Third has gone to cluster number 1. Fourth has gone to cluster number 2. So these are all you can verify. Clustering vector. That means which item has gone to which cluster. Now question is how many people are there in cluster 1? Those who are 1, 1, 1, they are actually falling in cluster 1. How many? 1, 2, 3, 4, 5, 6, 7, 8. And those who are given number 2, they are falling in cluster number 2. Those who are given number 3, they are. So how to check this? result size. So if you look at result size, it says in first cluster there are 8, in second there are 6, in third there are 6, right? And total was 20. Is that clear? Yes, please.
Yes, sir.
So basically it has made 3 clusters, and those 8 people, they are having similar properties. The next 6, they are having similar properties, and the last 6, they are having similar properties. So from the entire data, 3 clusters have been made. If you write down the names, say 111, let's say Ramesh, Rama, so and so. So these 8 people, they are put into one cluster. Next 6 people, those who are having 2 names, 2, they are put into second cluster. Those who are 3, put into third cluster. So this is how the clustering goes. So this technique is called cluster analysis. I think I have covered most of the topics which have been assigned to me. If you need any question or query, you can ask me. Yes, please. Any question, anything which is not clear, you can ask me.
Sir, for cluster analysis, would you leave the presentation with us?
I will give you this. I'll just today give you the entire file today of the coding, and then you can try on your system. Make a file and make a file. I'll send you some files also, which I have used by tomorrow, because today it will take around 1 hour to, I mean, you make a folder like Vishwa Bharati or maybe anything else, then you need to change the name of this, and I'll send you these files. First file will be like multiple.csv. So once you have that file, you will be able to open that file. Then also test1 file, clustering file, all these files will also be sent to you in Excel with CSV format. And you can try all this at your end. Is that okay?